Hey everyone, this is Prashant Gandhi. I'm responsible for Big Switch products at Arista, which are Converged Cloud Fabrics or CCF and DANZ Monitoring Fabric, DMF. And I'm going to be speaking to you today about some of the innovations we are focused on in the DANZ Monitoring Fabric and kind of what is the inflection point that is driving us to look at the monitoring infrastructure and modernize it for the next decade. So, the monitoring challenges are well understood, and typically the operations team, whether it's NetOps or SecOps, really want to figure out, certainly on the NetOps side case, is the network available? Can I prove the innocence of the network? And on the SecOps side, really, what happened yesterday incident? Can I replay this incident? Can I detect the anomalies? By observing network traffic. And so these challenges have been there, and they're getting extenuated by the fact that we have dense infrastructure. Folks have east-west applications, east-west traffic that is equally important, becoming mission critical. So it needs to be monitored. Endpoints are everywhere. IoT is not helping, right? And the budgets are not growing. The teams are not growing. So you can't break the bank as we are. As the need for monitoring continues to explode. And the other is how rapidly can we do this? And, oftentimes network is the first one to get the blame, right? So proving the network innocence or reducing the mean time to innocence becomes very, very important. Typically, over the last 10 years, we have leveraged network packet brokers and various tools to do traffic monitoring, primarily north-south traffic. But typically, we end up having multiple consoles, right? There's the NPB console, then there is the network analysis console, then packet capture console, and we go from keyboard to keyboard and console to console and try to hop and hunt and figure out what the incident was and how do we address that. The environment is not scale up, it's very expensive, and that's why modernity has not come to the space. And so the question is, what are the principles of modernity that we can apply here? How do we do this? And we look back on what happened in networking, and at Arista, what has been done is really leverage cloud principles and bring those into on-prem networking. And the approach here is exactly the same. Why not bring cloud-style architecture to the traffic monitoring space, to network packet brokers, to enable pervasive visibility, north, south, east, west, across campus and edge, as well as data center. And this starts with, leaf-spine architecture, which provides us the scale-out capabilities, ability to manage and operate everything through a single dashboard, through the controller, which again, just cloud principles, go to one dashboard to do everything. And cost-wise, really, Ethernet economics is what drives us. So no proprietary hardware. Let's leverage Ethernet switches. There are dense switches. The price performance is the best in the industry. And as fabrics move to from 1040 to 25 gig, 100 gig, we need the price performance of Ethernet and the density to be able to monitor more and more. And then the next aspect is, are we just going to push packets and basically get the tap and span ports, aggregate them on the monitoring environment, and then push it out to the tools? Is that the only role of the monitoring environment? Or as we move into a more modern architectures, can we do more? And the answer is absolutely, we can do more. Why can't we bring analytics? Why can't we record traffic so we can go back in time and rewind the network state and replay the incidences? Why can't we bring context to this environment so there's more meaningful data beyond IP address and MAC addresses, right? Can we bring autonomous capabilities to monitoring through machine learning and additional sort of intelligence and inference? And also automate, not only first-party infrastructure, but also third-party environments, and truly bring the speed of monitoring and issue resolution to modern era. So let's take an example. How do we deploy such a system? All right, here is I'll kind of focus the attention on the data center. We have north-south traffic. We have east-west traffic. Start with couple devices, couple Ethernet switches, connect them. have them, they're managed by the controllers, the DANZ Monitoring Fabric controllers. Want to monitor north-south traffic. Typically, that's where folks use taps and bring that traffic into the monitoring fabric and send it over to the tools. What about east-west traffic? Not a problem. Take your leaf links, your spine links. These are moving to they're typically 40 gig up to the spine, or 100 gig now moving forward. Bring those into the monitoring environment. Just add more switches to the ingress layer and address that. If you want to add more tools and more teams, you can offer this as a multi-tenant monitoring environment to various teams, whether it's NetOps or SecOps or application ops teams, and simply scale the egress portion of the fabric. More racks are coming, want to monitor more, not a problem. Just keep increasing the leaf spine architecture here. You can also have multi-tiers with a middle spine layer as well. If you want packet monitoring, or I should say modification capabilities like header stripping or deduplication, not a problem. Just add these service nodes, which are DPDK nodes. They can be clusterable at very high bandwidth, all the way from 40 gig to 320 gig, and you can have multiple ones to be able to monitor, get terabits of performance. And finally, data and context. And this is really done by integrating analytics, network analytics, into this environment and attaching packet recorder and fully integrating it into this environment. And when we add these capabilities, really, if you look at the name of the product, DANZ Monitoring Fabric, DANZ stands for data analysis, data analyzer. And that's exactly the purpose here, to bring this new level of visibility, deep visibility, to get us to what we call network observability or pervasive network observability to the monitoring environment. And why is that important? And I'll give a quick analogy. If you've seen the Avatar movie from 10, 12 years ago, there is this forest that looks like a standard forest with trees and leaves and branches. But when the night comes, it lights up and all the colors are there and the context is there that you could not see during the daytime. And we see that, by adding these analytics and recording capabilities and context, you get to that level of visibility that is needed to do deep and rapid root cause analysis. Now, what data do we feed to this analytics node and recorder node? So, variety of data. You can have the production network feed flow data. If the production network is not able to generate flow data, not a problem. You can have the DMF itself generate flow data from the packet that it is receiving and send that to the analytics node. The service node can also generate IPFix data. So all of that can be generated right from DMF itself. Interestingly, network, we know, is kind of the central nervous system for applications. All the packets flow on the network. When they're captured through tap and span, they all flow on the monitoring network, the DMF network. So we can generate metadata. We can enrich the information that we see, create it into metadata and context, and send it to the analytics node. And exactly that's what happens with DMF. And finally, the raw packets can be captured right into the recorder node. So great, all of this is there. But what about other things like users and device context? Well, some of it we can glean right from the packets themselves. Others we would integrate, and we today integrate with VPNs. We integrate with IPAM systems. We integrate with AD in order to get and correlate this information so that you have rich level of data and context to do the analysis and root cause analysis. So now,
Prashant,
yes.
Before you go forward, so on the previous slide, you were talking about sending NetFlow into the fabric. What's the advantage of sending NetFlow in versus having the DMF just get that information from the packets it's seeing?
Yeah, it is primarily for how the end users, customers are familiar with. If they have tools built with NetFlow, then they like to leverage that. But typically, we are seeing IPFix and SFlow is providing sufficient information as well. Does that address? Oftentimes, also customers they don't want to turn on NetFlow on production devices.
Well, yeah, I understand. I was just curious, why you sort of mentioned that it was, you do both, and I wasn't sure why you would add the overhead to the production network if the DMF was already doing it. So thank you.
Yeah, different customers have different kind of needs. Some turn it on, some don't want to turn it on, but their tools still rely on that data, right? So perfect. Thank you. And then how do we integrate these things? And so this is what we have done to address specific use cases, which is how do I rewind the network state? So analytics node and recorder node talk to each other. They're integrated. They're all managed by the same controller. So it operates as a system. And it's like, these two nodes, analytics and recorder, they're like yin and yang. Each one has its own energy, but when you put together, it's truly complete. I mean, it gives you the power of that completeness. And so how do we see that? Well, when you get, an anomaly, detect that on the analytics node with a click of a button. You can go to packet recorder, get the flow analysis from packet recorder, PCAP from the packet recorder, play it back onto the analytics node, or send it to any other tool that might be able to do deeper analysis. So this level of integration is built in. And what I wanted to do was to do a quick demo of this to show you these capabilities and integrations that is already shipping. Okay, so let's start with that. We'll get into sort of moving, elevating ourselves from monitoring to pervasive visibility. The analytics node has various dashboards and functional menus to do application dependency mapping, machine learning, and things of that nature. We'll focus on the standard network analytics. You want to find out who's talking to who. You can see the source as the inner ring. Outer ring is the destination that it is talking to. What applications are being leveraged for this communication, and you can also zero in into the specific time period and look at the activities. The search can be very contextual. So, for example, show me all the Polycom devices, either source or destination. You can easily search there and find details about those communications or flows. Easy to get top talkers information, and then also correlate the user information with the top talker. And we have obfuscated all that information, but that's where it would show up for the network team. Now, as clients are talking and various devices are talking, do you have the right OSs and the compliant versions? You can find that out very quickly from the dashboard here. New host, oftentimes performance issues happen when new hosts join the network, and so you can identify what are the new hosts joining in the network for the last 24 hours, and more importantly, where did they show up the first time in the network? Which switch did they come from? And that allows one to then get that information. So now the next item I wanted to show was the integration of analytics node and the recorder node. So now this is really the cool use case here. Let's say application reports that the network is slow, or the user reports that the network is slow. You can go and look at the time period, identify the flow spec, the source and the destination, and maybe the protocol, and all of that information gets automatically populated into the dashboard here, the blue dashboard. And then once you click submit button for flow analysis, it goes and talks to the recorder node. And now you can do all the TCP analysis, HTTP analysis, SIP analysis. The variety of protocol analysis is available to identify performance measurements. If you want to do app identification, not a problem. Again, a query can be sent to the packet recorder, and you can identify hundreds of applications, and the usage there. If you want to get a PCAP, very hard to do this across multiple consoles. Not a problem here. Click of a button, PCAP is right there. Click it and send it to the tool of your choice. If you want to replay, oftentimes in security world, replay of an incident is important so that you can actually see how the threat is evolving, and you can recreate that. And packet recorder and analytics node, that combination can allow want to replay the recorded packets at the rate at which they were recorded, or at a faster speed or a slower speed to a security tool. Anomaly detection. So analytics node has built-in.
Question.
Go ahead.
I noticed that last screen said 8 months ago. How much information is this collecting? And obviously, it has to be some sort of metadata, because it's not possibly keeping 8 months worth of information.
Yeah, I should. So let me kind of talk about two things. Analytics node collects metadata, and the packet recorder collects the actual raw packets. And so packet recorder is 192 terabytes, and you can cluster them so customers can have that information for anywhere from several days to a week, depending on their traffic patterns. And the analytics node can be several months. This is kind of a lab environment, so you see 8 months, but the metadata can be stored depending on the size of the network you're monitoring. Also, all of these are clusterable, so you can just keep adding more analytics node and get more capacity. And same thing with the recorder node.
And is this available as a service and as an appliance?
It's today offered as an appliance, so it would be on-prem because it requires high-performance compute, and data is on-prem, and customers are very sensitive about the data, so it's available on-prem, but all integrated in the DMF environment. So it's a one dashboard. All of the lifecycle management, everything is done through the controller.
So is it collecting data or just the header information?
It's collecting. So analytics node collects flow information and metadata. Okay. And the metadata is enriched data from headers as well as control protocols like TCP, ARP, and other control protocols at layer 2, layer 3. All of that information is aggregated, enriched, and sent to the analytics node. What's important for analytics node.
Okay, thank you.
All right, perfect. So let me wrap up. So where are we going? And as you can see, we have already done integration. Everything is run through API. So that has allowed us to do the integration between the tools that DMF manages, which is recorder node and analytics node. But we see tremendous opportunity to integrate with third-party tools. Some of it we have done. Now with Awake as part of the Arista portfolio, we have that opportunity as well, being a security tool within the Arista portfolio. And then leveraging the APIs on CloudVision to then integrate, take actions. So if you want to assign an ACL on the data center switching network, we can integrate that through CloudVision. So we see these opportunities. We see Arista in a unique position where we have the data center switching fabric, we have the monitoring fabric, we have the tools like analytics, recorder, now the NDR tool with the Awake acquisition, that we can do a ton of first-party integrations through this federated, communication and programmability, and also third-party. Same APIs can be leveraged by third-party as well. I will stop here, and
so
over to you.
Question. Sorry, so many questions. So the end goal is that now that you have Awake, is that you're going to also be able to do the enforcement piece. Is that correct?
So Awake is an NDR tool, network detection and response. And so as the space evolves, the whole approach with NDR is to be able to detect and respond.
Right. So with the DANZ piece, then with the integration of Awake, will the enforcement be something that will be automated? Is that an
that's certainly that's where the puck is moving, and the question is, how do we do the automation, because it will require change control to be part of that. But the question is, can we do remediation, which might take hours into minutes, and that's really the goal.
Yep. Thank you.
Prashant, this is Tony. I have a question while the next presenter is getting ready. It looks like the DMF is geared towards all of the on-prem switching and fabric. What about the cloud access? You know, a lot of people have split resources on-prem and in cloud. And how do you get that visibility in the cloud? Is there a VM? Is there a way to plug in to grab packets from the cloud?
Yeah, absolutely. And I mean, cloud providers are also seeing that sensitive applications are moving to cloud. So they have started to provide the TAP APIs. The tool owners are also looking at providing the tools, the virtual tools into the cloud. One of the challenge, of course, is that the cloud does not have a notion of packets. So we have to kind of look at that. But certainly, as Arista, we have Cloud EOS as a cloud platform already, and we see an opportunity to kind of bring visibility to cloud environments as more and more customers are going to start demanding that. But today we are on-prem. We've done demonstrations of how we can leverage this in the cloud, and as that demand picks up, look for us to kind of deliver solutions in that space as well.